Okay, and as we model 6.2 using our exponential formulas, in example 1 and 2, we'll let you work on these. Read the example. What I've done is I've taken the standard formula and substituted in there. I should actually put for our t here 12 years, okay. But using this general formula, I've written it big, and you want to put that in your calculator and round to the nearest whole person. And then for number 2, again, they're showing you the formula. So it's a matter of substituting into the formula these values and then see what you get. So this is going to be a twofer, and we'll pause and give you a chance to do it as well. Did you get something like this? Now here, noting that it was a declining population because of the negative exponent, notice it went from 350,000 to 265,000, indicating a decline. So this number would seem reasonable. And then here, due to inflation running at 2%, today it's running a lot higher than that, a $71,000 home in 14 years, if it were just at a little bit over 2%, would be now worth 100,000. Now, there's some economics involved here that we're not going to go into. We'll save that for another course. All right, let's move on. Now, for examples 2 and 3, let's set up the background of what the resulting functions would look like. And then that'll be the check. And we'll work on 3 and 4. Now, as we look at number 3 and doing our substitution in the formula, remember 1 minus this, we could make this a 0.7 right away here that we're going to square. So 0.7 squared multiplied by this will give you what? And then again, doing this formula and this formula, this is account 1 and this one is account 2. Well, just shooting from the hip on this, quarterly at this lower percent and monthly at this higher percent, seems obvious that number 2 would be the answer, but do the math and check it out. Okay, checking the answers. This original amount, 1,032 after 2 years with depreciation, was now worth $505.68, rounding it to 2 decimals. Here, as we brainstormed and shot from the hip, the future amount would be this. Here you can see this is $45 more than that, so the account 2 would be the better buy, and this is the protocol of using this exponential function method. Now, at looking at these, number 5 gets challenging. So take a moment to read it and see if you could figure, and we're using this as compound interest. So this will be our formula. And see if you can kind of substitute into this. Now the tricky part here is they're giving you the amount of interest you would earn in this many years. So you had to take your initial principal, which was this amount here, and add this interest to it to get the new future amount that is now here. And since it's compounded annually, our n here is 1, and then 1 times the number of years, which is 3.6, just gives us this. So to simplify a little bit here, we can eliminate this 1 here, and this is our formula. So we want to solve for this letter R. We'll do this one together, and then you can see the protocol. Now, the first thing we're going to do is get rid of this by dividing both sides by this. So all of this then becomes a 1, which I'll now erase. And you might say, well, what's the next step? Well, I want to get this R, in a sense, by itself. So I'll put this in black so you can see the difference here. What am I going to do to this side to get the R by itself? Well, I want to get rid of this exponent by taking the 3, I didn't get black, I got yellow, 3.6 power of both sides. So the 3.6 of this side equals the root 3.6 of this side. Here, because our index number and this exponent are the same, just becomes the radicand. So I get 1 plus R. I'm going to subtract 1 from this side. So when I get this value, putting that in your calculator, I'm going to subtract 1, and then that'll be our next step. So I'll do this on mine. You could do it on yours. But before we do that, let's convert this so we can put it into our calculator. This would be 121200 over 1, 2, and then 4 zeros. Put that in parentheses, and this is going to be raised. Remember, there's a 1 there, and this becomes the fractional denominator of our exponent here. So this is 1 over 3.6. So now you can put that into your calculator. This in parentheses, caret, and then 1 divided by 3.6. And let's see what you get. And then we're going to subtract 1 from it. And then we need to round it to 2 decimal places as a percent. So let's take it in steps again. I put this in parentheses, caret, this in parentheses, and I got this. Then I brought that 1 over. I'm going to subtract 1 from this, and I get this. Now I need to round this to 2 decimal places in percent form. So converting it to percent, I move the decimal place 2 places over, which is here. I get 2 then. This is 7, but I have to go to the 3rd decimal place, which is a 6. So I'm going to make this 7 and 8, and there is my answer. Now, you could put this in this original formula here, raise it to this, and you should get this number here as the future value. I'm going to do that now just to try it out. And I didn't quite get the 12 here. I got a 14, but again, this part, yeah, I got like $14, but again, this is rounding off. So this is a good answer, 0.28%. All right. Number 6, again, give you a moment, pause, and see if you can come up with the proper substitution into the formula. Something like this. So there's the 0.08. There's my 1, Euler's E. Notice we have to put that in there as a subtraction here. But here you have to put this negative sign in as a negative number times 9. So I'm using an extra set of parentheses. Again, check it out so you get the correct answer. Be sure you know how to use your calculator for these. So I get this, and notice we're starting with 0.08, and this is a negative value, so we're getting 0.0667 goes on. We want to round to 3 decimal places. So we go to our 4th decimal place, it's a 7. So our final answer would be 0.67, rounding this 6 up 1, dropping this part here. Again, part of this is knowing the protocol, following the instructions, and rounding correctly. Generally, you don't round until you get the very end of your answer as you put things into the calculator. Going on now to number 7, take a moment to read the example. And I'll go over it with you. The revenue function is this, which is what I've written here, where X is the number of units sold, and the P of X is defined by this. Okay, so let's start to fill in what we have. R of X. Now our X value, they say, is 16 units. So that's 16 times what we have here, 34 times 2. That's right from here. But now we have a value for X. This is going to be a negative 16, which is our X value here, divided by 4. So what is a negative 16 divided by 4? Did you get a negative 4? I just want to erase this now, and I'm going to put a negative 4 here. I just wanted you to be sure you knew where it came from. All right, so this value becomes negative 4. Now, does this negative 4 apply to everything here, or just to this base? And the answer is just to this base. So this then can be read 16 times 34 over 2 to the 4th power, as using our exponent rules here. If you have 2 to the negative 4 over 1, that becomes 1 over 2 to the 4th, bringing that negative sign across the division bar. It changes its sign. And what is 2 to the 4th? 2 to the 4th is 16. So can we do this? Yes. Just wanted you to see where it came from. Now, what happens here? I don't have to multiply this. I have a common factor of 1. So my answer then for number 7 is $34. Now, again, as you're doing your practice and practice, down over toward the bottom here is a little tutorial bar that if you get stuck on something, you can use that to help. Now, for our last example, we had one like this already. So again, read it carefully. I will be substituting into this formula, and you substitute. Then we'll go over the protocol together. So something like this, we had to add this 500 in interest to our principal. So our future amount is this. And again, we had one like this just a little while ago. So we're going to divide both sides by 5,000. And look we could knock these off right away, and this all becomes a 1. So to keep our works a little more simplified, what do? Well, we take the 3.6 root of this side and 3.6 root of that side. Remember, this is going to be 55 over 50, and the exponent is 1, which is the exponent there, over 3.6 equals just the radicand here, 1 plus r. We're going to do this, get a value, subtract 1, and then round the rate to 2 decimal places. All right, I'll do it on my end. You give it a try on yours. So this side, when I took this 3.6 root of this, I got this decimal. I'm going to subtract 1 from it. I get this, and there's 2 there I could add. I want to round to 2 decimal places as a percent. So I'll put it up here, 0.02682. Now to convert it to a percent, I move it over 2 places. And then to round our decimal in 2 places, I look at what's in my third, which is a 2. So I'll just drop it. So the answer to number 8 then is 2.68%. Okay, well, you'll get yours. Hopefully this was helpful, and we'll continue on. Now, in our next topic, we'll be doing logarithms, which is another way to work with these exponents. Logarithmic form and exponential form have a relationship, and we'll go over that in our next lesson.